In this illustration, we'll see a situation for a sinking balloon which is to be lifted up. Here we are given that the basket of a hot air balloon consists of a man, some packets of total mass m. On balloon, there is an upward lift force which is constant, but due to some defect, it is less than the weight of basket. As a result of which, balloon starts sinking down in air at acceleration g/3. This is in downward direction. And the man decided to drop some of packets so that balloon will ascend up at acceleration g/2. So here we are required to find the total mass of packets to be dropped for this. Here in this situation, if we draw the case, say if this is the basket of balloon and say this is the balloon, and say in this situation the balloon has a total mass m. And we are given that it is sinking down at an acceleration g/3, and this because downward its weight is acting as mg and upward, say the buoyancy force acting on it is fb, which is the upward lift force on it due to the buoyancy of air. So here as fb is less, here we can write initially mg minus buoyant force is equals to m multiplied by g/3. Here we are given that the total mass initially is m. I have taken it capital M, but that's fine just to understand. And in this situation, as it is going down, now to accelerate it up, say if some mass is removed from it, say if m1 mass is dropped from balloon, then we use, here if you reduce the mass by m1, you can say in this free body diagram the mass will be m minus m1. Downward weight acting on it is m minus m1 multiplied by g, and the buoyant force will remain same, the lift force, because it is due to the size of balloon. We consider this is constant. We are also given that it is constant. So here we can say when this mass is dropped, it will start going up with an acceleration g/2. So here you can say after dropping the mass, we can write equation of motion will be fb minus m1g is equals to m minus m1a. Acceleration here is g/2. If this equation 1 and this equation 2, we can add these equations, so this fb will be eliminated, and here we can write, if we add these equations 1 and 2, this will be mg minus of m minus m1g is equals to this mg/3 plus m minus m1 times g/2. If we further simplify this equation here, you can see this mg minus mg/3 is 2mg/3. So this 2mg/3 minus mg plus m1g is equals to mg/2 minus m1g/2. Here if we further simplify from here, you can see this left hand side term can be taken on the right hand side, and this term can be taken on the left hand side. So this 3/2 m1g is equal to this side is mg/2, and this is minus mg/3, so this will become plus mg/3, and this is 5/6 mg. Further, if we simplify here, g gets cancelled out, we can also cancel this 2. So the value of m1 here, we can see we are getting it as 5/9 times the total mass of the basket, which is the final result of this problem.